All right, so we will, like I mentioned, be retaking section 1.2 because we're adding some more standards to that, or some more concepts to that standard. All right, the first part of this lesson is supposed to be totally review. We already did this with quadratics, so I'm going to go kind of quick. It says, by looking at the graph of a function, you can determine the function's domain and range and estimate the x and y intercepts. The x-intercepts of a function are also called the zeros. That's what our calculator calls them, and we use second trace to find those zeros. Sorry, I should have had this up and going. So if we wanted to find the zeros of this, so we'd go second trace and we'd pick 0. And that would be finding the x-intercepts. Okay, what just happened? Hello. There we go. And then remember, to find the y-intercept, you always just are looking for x equals 0. So you could go back to the calculator and pick value 0. I'm too lazy and I just do trace 0 because then I don't have to do the whole second trace thing. You could even look at the table, but if it's not a nice number, it's not going to show up, okay? It's not an integer. The x-intercepts, the solutions of the corresponding equation are called the roots of the equation. To find the zeros of a function, set the function equal to 0 and solve. If you are able, okay, so right here on your notes, x-intercepts are points where a graph intersects. Oh, intercepts, it doesn't say x, I can't read. Intercepts are points where a graph intersects the x or y axis. Sorry, I confused myself. The x-intercepts occur where y equals 0, or where a function equals 0, and an y-intercept occurs where x equals 0. A function can have no or more x-intercepts, but at most one y-intercept. So when we get to doing some crazy business like this, polynomial business, we will have like 4 x-intercepts, but it will only have at most one y. Can anybody tell me why? Why can't it cross the y-axis more than once? Wouldn't be a function anymore, right? Because it wouldn't pass the vertical line test. Oh, this is very small. All right. Domain is x values left to right and range is y values bottom to top. Use the graph below to find the domain and range. Can anybody tell me domain and range of that parabola? What's domain, guys? Yep, all real numbers because it's getting wider and wider. Everybody good with that? And then range bottom to top. They've given us a point over there on the picture. So the range is negative infinity up to, what is that y value at the top? 5.0625, is that what it says? Okay. Again, that comes from the y value of the, what would they have used on the calculator to find that spot? Yep, the max. Okay, and the range uses the y. All right, the y-intercept is the point where it intersects the y-axis. So if you put in a 0, it appears to be about 4.5. Likewise, the zeros are where it crosses the x-axis and appears to be about -3 and about +1.5. To find the y-intercept algebraically, we would put in a 0. This would be 0, this would be 0, this would be plus 4.5. So indeed, it is exactly 4.5. Algebraically, to find, we would have to set it equal to 0. They took out a -1 and factored what was left and found out it is exactly -3 and 1.5. Okay. So we're going to use this graph and find the domain and range and x and y intercepts, and then supposed to do them algebraically. But can anybody tell me what they think The domain is left to right. All real numbers, okay? Because it's going, the arrow's going left and right. Everybody okay? What about range bottom to top? Is it going down further and further and up further and further according to those? Yeah, it certainly appears so. This is a cubed root. It says 4 cubed roots of x minus 1 minus 4. Did you know that you can cube root a negative number? Okay. If I put it negative 7 in here, negative 7 minus 1 is negative 8. What would the cube root of negative 8 be? Negative 2 times negative 2 times negative 2 would be negative 8, right? So because it's an odd power, you can actually put a negative number in there. All right. Y-intercept, where does it appear to be crossing the Y, guys? Anybody? Be careful. Ooh, be careful. What are they counting by? Yeah, they're counting by 2's on the y-axis, so that appears to be negative 8. So if I put that in, they want us to check it algebraically. I'd have 4 times the cubed root of negative 1 minus 4. What's the cubed root of negative 1, guys? Negative 1 times negative 1 times negative 1. So it's just negative 1. So 4 times negative 1 minus 4 would be negative 4 minus 4 is negative 8. We have it exactly, and that proves it algebraically. All right, and lastly, the x-intercept, where does it appear that it's crossing the x, guys? 2. So that would be 2, 0 as the only x-intercept. And we would have to set the function equal to solve algebraically. If we added a 4 over to the other side, we would divide by 4 and get 1. How to get rid of a cubed root? Anybody? I don't care if you don't write this down. How do you get rid of a cubed root? Cube both sides. So if I do this side to the third and this side to the third, I would just get 1 equals x minus 1, and I'd get x equals 2, and that's what we said here. All right. You're not going to have to do a lot of crazy algebraic stuff today. That was just an example. All right. Use this graph, it says, to estimate f of negative 2.5 and f of 1. This was on the quiz last week, and it went okay for most of you. I had some people who skipped those questions and acted like they'd never seen them. This is if x is negative 2.5, what is the y value on this graph? So if I go over for x equals negative 2.5, can you tell me what it appears that the y value is? 12. And then it says f of 1. So if I go to x equals 1 on the graph, it appears, anybody? I would say 5. All right. It does say confirm algebraically, so we're supposed to put them in here. Real fast, if we put in a negative 2.5, that would be negative 5.5. Absolute value would make it positive 5.5. That would be 11 plus 1 is 12, so that one works. If we did this one algebraically, so we put in a 1. This would be negative 2. Absolute value would make it positive 2, so 2 times 2 plus 1 would be 5. Questions? Again, domain and range, real quick. Anybody got the first one? What's the domain here, left to right? Negative infinity until what x value does it end at? 4, and it appears to need a square bracket. Everybody okay? Left to right? What about bottom to top? Giving you wait time. What's the bottom? Negative infinity. And the top? Yeah, this is counting by ones, right? -1, -2, -3. So this would be +1, +2, +3. And it is a square bracket unless there's an open circle somewhere. What about number 4? Number 4 is tricky. Domain is x values. What is the only x value that you can't put in? 0. There's an asymptote here, and they happen to give us the function. The only thing we can't do is divide by 0. Now, it is very hard to tell, but this is getting closer and closer, so it's only exactly 0 that doesn't work. You can tell that from the equation. But to write that, if we were using interval notation, would be this. Or we could say all real numbers except x cannot equal 0. That's supposed to be an R. Sorry, that's a mess. And then the range, what about bottom to top? We're good, we're good, we're good, we're good. And then it stops and starts over here. We're good, we're good, we're good, we're good. So what is the value here? The equation of that line is y equals 0. So the range is also everything except 0. Oops, that would be y cannot equal 0. So here, if you look at that expression, you can't put a 0 in, and -2 divided by anything will never become 0. All right, now we're on to the new stuff. The assignment on this is on Delta Math. It's like 15 minutes worth of work, but it's broken into 1.2a and 1.2b. So there's 2 assignments on Delta Math tonight, but I went to go in and put them together, and some people had already done 1.2a, and so I decided I should leave it because I didn't want to mess anybody up. All right, this is one of the hardest concepts for students, and I'm not really sure why. It says a graph is a relation that is symmetric to the x-axis or the y. A graph of a relation that is symmetric to the x or y axis has line symmetry. A graph of a relation that is symmetric to the origin has point symmetry. Okay? So these would have line symmetry. And this has point symmetry. I'm not going to ask you that. Okay. The x and y, x-axis and y-axis are common lines of symmetry. You did symmetry in geometry, yes? It's been a long time, and I think you talked about symmetry in Algebra 2, but maybe not. I don't know. What is wrong? This one, the x-axis goes right through the middle, and that's a line of symmetry, right? So x-axis symmetry, what's wrong with that? In terms of why don't we talk much about that? Is that graph that has x-axis symmetry even a function? No. So x-axis symmetry is not a function. But y-axis symmetry is super important, and we're going to talk a lot about y-axis symmetry. Now, to have y-axis symmetry, the y-axis has to run right through the middle of the graph. Okay? When you see a picture like this has a vertical line of symmetry, but it's not the y-axis, right? Everybody clear? All right, point symmetry is the one that kills people. Point symmetry is also called symmetry with the origin. Okay, the origin is a common point of symmetry. Origin symmetry guys, means you have to be able to rotate this picture 180 degrees and it looks identical. So it goes lower left to upper right. If you flipped it 180 degrees, it would look exactly the same. Okay. And it's got to be around the origin that you're flipping it. So when we start talking about symmetry, graphs, the line symmetry are folded along a line so that the two halves match exactly, where graphs with point symmetry are rotated 180 to appear unchanged. The three most common types of symmetry are, this is x-axis symmetry. And again, the test for that algebraically is you would replace y with the opposite of y, and you'd give an equivalent equation, and I'll show you some of those tests in a minute, but this one is not a function. If you have a graph with relative symmetry to the y-axis, like this one, okay, this is the line of symmetry down the middle, you replace x with the opposite of x, and it will result in the similar function. Guys, what that means is if I put a 2 in and get out a 3, we'll say, if I put in a -2, I will also get out a 3. Does that make sense that it's the same on the left and right side? Okay. The graph of a relation is symmetric to the origin if and only if, okay, it looks the same if you rotate it 180 degrees. But the other thing is, if you replace x and y, you will get the opposite of x and y. So if this point over here was, say, 3, 4, there would be a point down here that was -3, -4. All right? So on your notes, one more time, it says for every point x, y, if it's x-axis symmetry, the point x opposite of y is also on the graph. So replacing y with opposite of y results in an equivalent equation. For every point, if it's got y-axis symmetry, you change the sign on the x. And replacing x with the opposite of x results in the same equation. For every point x, y, if it has origin symmetry, you replace both x and y. So replacing x with -x and y with -y results with the equivalent equation. All right. There are some shortcuts to some of this, and most of the time I'm going to just give you an opportunity to graph it and be able to tell from the graph the kind of symmetry it has. All right. Now, how are we doing on symmetry? So what kind of symmetry does this have? Anybody? This would be y-axis. What kind of symmetry does this have? If it were better drawn. Whew. That's a negative sine curve. But that would have origin symmetry if it were halfway drawn decently, okay? Those are the two important ones. Functions that are symmetric with the y-axis are called even functions. Okay, a function is called even function if it is symmetric with respect to the y-axis. And again, the test for y-axis symmetry is to replace x, y with the opposite of x, y, and it'll stay the same. Okay, you could say those are equal. A function that is odd means it has symmetry with respect to the origin. And the test there is if you have an xy and you replace it with the opposite of x and the opposite of y, you'll get the same answer out. Okay. I guess they wrote it in function notation if you wanted to. F of opposite of x equals f of x. I shouldn't write that there. Let me put that on there one more time. For this one, it's f of negative x equals the same as f of x. And for this one, it's f of negative x equals the opposite of f of x. All right, sorry, I didn't put what they wanted in there, but it's the same thing. Okay. Everybody got what they want off that slide? I'm not going to ask you, I'm just, those definitions, we're just going to look at them. Okay. Analyze the graph to determine whether this is even, odd, or neither. What do you think? Does this have any symmetry? It appears to have what kind of symmetry? Origin symmetry, okay? Which would mean if it is a function that has origin symmetry, it is called odd. All right, they replaced, look at the beginning, okay, so it looked like this. You don't have to write all this down, but just follow here for a minute. So there's like a -1 out there, right? Then they replaced all the x's with the opposite of x. So they made this. This became a -1 cubed is still a -1. And it's times this -1 out here. So negative times a negative would be a positive x cubed. Oops, I'm sorry, back here, I forgot to write a negative. They replaced that one with a negative. So 2 times a negative x would be -2x. What they're saying is that is exactly the opposite of what we started with. Does everybody see that they changed all the signs? If you end up with all the signs changed, so this wound up with an x cubed minus 2x. If you wind up with the opposite of all the signs, then it is an odd function. It has origin symmetry. All right, this is sounding all complicated and it's not as bad as it seems. All right, so is this on the next page? So I'm on 3 maybe, okay. Even, odd, or neither. What do you think about this one? Let's talk about the symmetry first. It appears to have what kind of symmetry? We can fold it along the y and it will match up. Everybody understand that? The left half would exactly match up with the right half. So y-axis symmetry is called an even function. What do you notice about the exponent powers on this question? Anybody? The exponents are both even. We're going to talk more about that as a hint, okay? Now, what about this next one? X times y equals 6. Is there any symmetry? If I turn that 180 degrees, will it look the same? Turn your paper if you're not sure. Will it look like that? Yes, so this has origin symmetry, which means if I put a negative into both of those, a negative x and a negative y, they would cancel each other out and I would get exactly what I started with, okay? This one, what's going on here, guys? It does flip across the X. Do you see that I could fold my paper this way? What else though? Could I fold my paper this way and the halves would match up? Could I turn it 180 degrees? Yes, okay. Is this a function? Not a function, but it has all those kinds of symmetry. So even and odd only apply to functions, okay? Something can be an even function or an odd function. I'll write that over here. What was this one, by the way? Origin symmetry was? I'm really confused on this last question. Did I mess this up? No, it should be the opposite, right? So what did I do here? If I changed, oh, okay, I know what it is. This is true if you change both signs, but that f of x says if you replace only, I didn't make a good explanation for that. If you replace only the x, then it should be the opposite of what you started with, which if I divide it over to the other side, I get this. Okay, anyway, yes, this is an odd function. Don't worry about my explanation. I just was confusing myself and I didn't want to confuse you. I should not talk. Okay, what about this one? This is trickier than it looks. I thought origin too, but can anybody tell where the origin is here? It's right there. Do you see where the X and Y are? This could have origin symmetry, except it's been shifted to the right one. So this has none. Okay. What about number 6? Okay, the y-axis runs right down the middle, so this has y-axis symmetry. What is that called then? Even function. All right, now we're supposed to do these algebraically. We can go ahead and graph them if that helps. Most of you would do that on a test or quiz. The first one says x to the third or x cubed plus, I forgot the rest of what it said, or minus x. Okay, if I do a zoom 6 or a standard window, I feel like we've seen that same graph several times today in various forms. What kind of symmetry does this have? Okay, it has origin symmetry, and it is a function, so it's an odd function. Now, we were supposed to prove that algebraically. The test for proving that algebraically is to put in a negative x and see if we get out the opposite of what we started with. So a negative 1x cubed minus negative 1x. Negative 1 to the third is negative 1. And minus a negative x is a plus x. Is that the exact opposite signs of what we started with? Yes. My question, what are the exponents on this problem? A 3 and how many x's are right here? A power of 1. So both exponent powers are odd, okay? That's a hint. All right, negative x squared plus 6. You can graph that in your calculator, but it's going to be up here at 6, opening down. So what kind of symmetry does this have? Y-axis symmetry, which makes it what kind of a function? Even. Okay, if it is an even function, what are the exponent powers here? How many x's are on this 6? 0. Does everybody understand that? Anything to the 0 power is 1, so x to the 0 power is 0 an even number? It is. Okay, 0, these are even exponent powers. The test algebraically would be to put in a negative x, and you should get exactly what you started with. Well, negative 1 squared is positive 1. I'd still have that negative on the outside, so it'd give me back what we started with. I know some of you that's just like, what is she even talking about? It's a good thing we can graph it, right? Okay. This one, any guesses by looking at the exponents? It has an x to the third, an x squared, and an x to the 1. Yeah, I'm thinking neither because it has even and odd exponents. Okay, somebody might have to read it to me. It was x cubed minus x squared minus 2x. Minus x squared minus 2x, is that right? Okay, if I graph that one, oh, very close, but can you see that it does not have origin symmetry? It looks like it would have a point over here somewhere that would be where it could be rotated 180, but it's not at the origin. So neither. And I'm not going to go with any great fun tests. Do you want me to show you that all the tests don't work? I can run through them if you want me to, but what could I replace x with here and it should come out the same? I can put a positive or negative number in there, and when you're going to square it, it's going to come out the same, right? Like if I put a 2 squared, I get a 4. A negative 2 times negative 2 is also a 4. So the x can change signs, which is called y-axis symmetry. So let's see if we go here and we put in square root. X squared minus 4, is that what it had? Okay. Weird graph, but does it have y-axis symmetry? And y-axis symmetry is an even function. All right. Down at the bottom of the page, I need you to make some notes. There's some extra room on this page, right? Okay. Do you remember what degree means? The degree of a polynomial, okay? The degree of the polynomial is the highest exponent power. So maybe just write down there degree equals highest exponent power. The degree is the highest exponent power. If you have an even degree as your highest exponent power, both ends of a graph will either go up or both ends will go down. No matter how many times it turns in the middle, both ends will go up or will go down. This has nothing to do with symmetry. Okay. An odd, so if this was an x to the 4th plus 3x cubed minus 2x plus 1, the highest degree is a 4, both ends go up. If it was a negative x to the 6th minus 2x plus 7, this is a highest exponent power of 6, both ends went down. If one goes either way, the highest exponent power is a cube, or is an odd number, sorry. I'm just making junk up, okay? If It could also go this way, one end up on the left and down on the right. This is called end behavior, and it's what we're going to talk about tomorrow. But odd degree, so it has an x cubed like this. Okay? The highest exponent power is odd, then the ends go opposite ways. There is odd degree and there's an odd function. So what I want you to write down, because it has to do with some questions in delta math, even degree but not an even function would be some things like this. Okay? Actually, this is not a polynomial, so I shouldn't include this. Let's do this. Those all are even degree because they're a power of 2 or a power of 4 or a power of 6 or a power of 8, but none of them are even functions because they have no symmetry. So both ends the same way. Both arrows are pointing up or down, but no symmetry with y-axis. Even degree and an even function would be when it's both ends up evenly on either side or both ends down evenly on either side. I didn't draw that first one very well. Okay. Odd degree and odd function. Odd degree means they're going opposite ways like this. Okay, but that's not, don't draw that. That's not an odd function. I wasn't paying attention to what I was supposed to be doing. Okay, odd degree, odd function. Something like that. It could even be real complicated where it goes down a little. Very messy. All right, that would be odd degree, odd function. Ends are going opposite directions and it has origin symmetry. Opposite direction of arrows, one up, one down. Last one is what most odd functions are, or most odd degree are. That's got opposite ends going opposite directions. This has opposite ends going opposite directions, but no, okay, opposite directions and no symmetry. I think we're going to talk more about this tomorrow, but I think there are some questions in delta math that might ask something like that. Both delta math assignments are super short, but please do them tonight so you have some practice on even and odd.